All right then, welcome back. So I got my cup of coffee. I think I'm ready to go. So I left y'all with the number line, okay? And I kind of condensed it a little bit and just added the metric prefixes. So what this section is conversion between different metric values or metric conversions themselves. So what I did is I put a couple of problems up here on the board. 8.6 microamps equals how many milliamps? So how many ohms are in kiloohms? So this is what we're doing. And I can tell you, it really just boils down to moving the decimal point. So what we have to realize is we consider this the question and that the answer. So I see a decimal point in this value, and what I have to realize is that decimal point is actually sitting on the number line on the micro spot, okay? So that means that this decimal point is sitting right here on my number line. Now I need to convert it over to milliamps. So that means I'm gonna have to move the decimal point to the milliamp section, or to the milliamp position. So I'm going to take and move that decimal point. Now to get over here to the milli point, I'd have to move that decimal point 1, 2, 3 places to the left. 3 places to the left. So if I take this value of 8.6 and I move it 3 places to the left, that would be 1, 2, 3 places to the left. I'm going to move that decimal point over there. And what do I do with those blank spots? That's right. I add zeros. So my value, my answer would be 0.0086 microamps. So, or milliamps. So in 8.6 microamps is only 0.0086 milliamps. So now, here we're going to convert 4,600 ohms to kiloohms. There's no decimal point in that number. Well, you know, every number that doesn't have a decimal point, we automatically assume that the decimal point is at the very end of the number. And so we automatically assume that that decimal point is right there. Now, that decimal point is sitting on our number line on the regular ohm spot. So this being the volt, amp, ohm, watt, that decimal point is sitting right there on that number line. Now, it's telling me I need to move that decimal point to the kilo spot. So I'm going to take this decimal point and I look up here from the regular ohm spot to get it over to the kilo spot. I need to move it 1, 2, 3 places to the left. So I'm going to take this decimal point and I'm going to move it 3 places to the left. So that's 1, 2, 3 places to the left. So my answer becomes 4.6 kiloohms. Now, how about them zeros? Can I put those zeros? Yes, I can put those zeros, but they really don't count for anything, so I don't see the point. Me, basically, if I don't have to do something, typically, I'm not gonna. So, yeah, if I don't have to put those zeros, I'm not gonna, but don't let that confuse you. 4.600 is the same quantity as simply 4.6. So 4.6 kiloohms and 4.600 kiloohms, same value. Don't worry about it. Okay? So now, 36 milliamps. 36 milliamps. Again, I got one that doesn't have a decimal point, so what am I going to do? I know it's right here behind the 6, and it's sitting on the number line on the milli spot. So that means that that decimal point is sitting right here on the milli spot. So I need to move it to the regular amp spot. So from the milli spot to the regular amp spot, it's 1, 2, 3 places to the left. So if I move this 1, 2, 3 places to the left, I got that space again. What am I going to do? Of course, I'm going to fill it in with a 0. And so I fill in that 0, so it becomes 0.036 milliamp or amps. So 36 milliamps is only 0.036 amps. And in this last one, we got 160 kilo ohms, or 160 kilovolts, 160 kV. We know that the decimal point, again, falls at the end of the value if there's not one. So I'm going from kV to V. So that means that decimal point is sitting on my number line on the K spot. So that decimal point sitting right there on the K spot, and I got to move it to the regular V spot. So I'm going to move it over here to the regular V spot. From the K spot to the V spot, I go 1, 2, 3 places to the right. So now this 160, 3 places to the right, 1, 2, 3. What do I do with those 3 blanks? That's exactly right. I fill them in with zeros. So 160 kV is 160,000 volts, because kilo is 1,000. So 160 kilovolts, 160,000 volts, same difference, okay? So these metric conversions are using the number line. You got to memorize the number line. And I say that, and you're going to be taking your quiz, sitting there at the house and all this stuff, and you're going to be tempted to look at that number line, and you probably will, but that's okay for the quiz. But you get back here in this classroom and you don't know this number line, you're going to have problems. I'm serious. Because I know what's coming up in this course, folks. And if you skip on any of the little tidbits along the way, you are not going to understand the stuff that comes at the end of this course. So make sure that you consume this. Know the number line. Be able to convert from one metric value to the next. It's moving the decimal point, okay? So it's not that bad. Moving the decimal point. So the next thing we need to talk about is the calculator. Now the calculator is what we're going to be doing all of our testing with. It's going to give us the analysis on a lot of these circuit problems. And so it's the basis of everything else to come, really. You understand the concepts, but then we use the math part to prove the concepts, and so on and so forth. So if you don't know the math or how to use a calculator, you're pretty much screwed. So bottom line, learn the number line, learn your metric prefixes, okay? So your worksheet will have 10 of these problems. So you'll do practice up on 10 of them and send that back to me. The calculator. This is the TI-36X, or the 30X. So this is the one that I teach off of. If you don't have one like this, good luck for the time being. But so this calculator. Now what we're going to be doing is we're going to be actually taking and performing equations similar to this. 3.9 microamps times 26.3 kiloohms. Well, the first thing that you got to know, folks, and at the very least consume this first, these are the four right in the center that surround the volt amp spot, the base spot. So learning these exponents along with these prefixes is going to be key. So for the mega, we know it's exponent 6. For kilo, it's exponent 3. For milli, it's exponent -3. And for micro, it's exponent -6. We have to consume this because I can tell you, there is not a kilo key or a micro key or any other kind of key on this calculator. So how in the world am I going to enter in the metric prefixes of micro? Well, I'm not. What I'm going to do is I'm going to recognize what the exponent is for that metric prefix, and I'm going to enter the exponent. So I recognize the metric prefix and the exponent that goes with it, and the calculator understands the exponent. We never write down exponents. We never read exponents. We always read and write metric prefixes, but the calculator doesn't understand metric prefixes. That's why we have to know the exponents that go with them, because we're going to enter the exponents into the calculator, okay? So now, first of all, you know, I can take and perform an equation, and I can come up with an answer that's 3.9615432 milliamps, let's say, okay? Now, do I need that much precision? No. Because what we're going to find out is there ain't nothing that man makes that's perfect, including electronic components. There's a little bit of error built into them in the first place. And then you start building measuring devices with the same components that have error in them, and you got error multiplied over. And so having this much precision with components that have error is useless. So we don't need that much precision. But what we do need is we do need at least 3 decimal places behind that decimal point, okay? So we need 3 decimal places behind that decimal point. Now, wouldn't it be nice if the calculator would automatically do that for us? Well, it does. And see, so what we're going to have to do is we're going to have to fix our decimal place for 3 places, okay? So if I look at the calculator and I look at the decimal point key, I can see the word fix written in green above it. Now notice there's this green fix key, or this green second key. Written above the key is what they call the second function. So to access that second function, I have to hit that green second key first. So if I want to fix my decimal place 3 places, I'm going to hit my second, I'm going to hit my fix, then I'm going to hit my 3 key. Now notice I've got 3 zeros behind the decimal point now, okay? I want to do this every time I use this calculator. I want to make sure that I hit the second, the decimal point, and then the number 3 key. This puts the calculator set to around 3 places. The next thing I want to do is I don't want to get these answers with all these zeros in them and stuff. I sure wish the calculator would automatically convert these in the correct metric proof. Wow, it does. It actually does. But I have to put it in the mode. So remember, there's scientific exponential notation and engineering notation. If I look above the 5 key, I'll see the SCI. That's not what I want. Above the 6 key is the engineering. So I want to put it in the engineering mode. So I come up here and hit the second key and then hit the engineering. And notice I get my little zeros behind the number for my exponents. That's where my exponents are going to go. All right. So to put it in the engineering mode, I hit the second key and simply the number 6 key. So this is what I need to do to my calculator every time I pull it out and start using it in this course. I need to have it round in 3 places, and I need it in the engineering mode. You need to put it in the engineering mode set to round 3 places, okay? So at second decimal point 3, second 6. That gets it in the engineering mode. Now, this value, 3.9 micro, well, where'd he go? He went that way and now he come back from there. So it's TV magic. All right, so what we're gonna have to do is we're gonna have to enter these values. Like I said, first thing I gotta know is that exponent for kilo is 3 and the exponent for micro is -6. So in order to enter that, I'm gonna enter in, okay, I'm gonna enter in 3.9. Now you see this EE key above the number 7 key? That EE key stands for enter exponent. Enter exponent. So I got the 3.9, so I'm going to enter my exponent. Little zeros pop up. And micro is -6, so I'm going to hit the little negative button down here along with the 6 key. Notice now my exponent says -6, so I got 3.9 exponent -6, and then it is times, so I'm going to hit the times, and then it's 26.3 kilo ohms, so I enter in 26.3. Now I got to enter in the kilo ohms, the exponent 3 for kilo, so I come up here and hit the EE key, hit the 3 key. Now I got 26.3 exponent 3, and I hit equals, and boom, I get a value, and it says 102.570, and it has an exponent -3. I will not write that exponent -3. My value that I would write as my answer, since -3 stands for milli, would be 102.57. Now remember, I won't put the zeros if I don't have to. All right. Now the units at this point really don't mean anything because we're not solving for anything. We're really just learning to use the calculator. So what did I do? I entered in 3.9, and then I hit my EE key, enter my exponent, and then I hit my change sign key. That's that one, made it negative. Then I entered in the 6 because micro is -6. Then I said times. Then I entered in the 26.3. Now that's kilo. So I had to enter my exponent. And kilo is exponent 3. And then I hit the equals key. So to enter that equation in, it was 3.9, enter exponent -6 for micro, times 26.3 exponent 3 equals. All right, so this is how we're going to use the calculator. You got to get to know this enter exponent. Watch this section a couple of times if you need to. All right, so the calculator isn't that bad. It's pretty much, feels natural, but enter exponent, EE key. All right, got to have it in the correct mode. Set it to round 3 places, put it in the engineering mode. Make sure that you know your exponents and metric prefixes, at least the ones in the center for now. I'm not saying we're never going to go into the gigatera, nano, pico area, but these are the ones we use most, okay? And so to enter this equation, again, 3.9 EE negative 6 for my micro times 26.3, enter exponent 3 for kilo. All right? Now, so y'all are going to get a worksheet. Worksheet will be coming out. It may very well already be there. So worksheet's probably going to come out with the assignment. Make sure that you work the problems on the worksheet. You turn around and send the worksheet back. And then next week, we're going to have the quiz on this, okay? So last week we did the whole intro and atomic theory. Today we had the quiz. Today we're getting the calculator, and next week we'll have the quiz on it, all right? So if you have any questions on this stuff, be sure to email me. Email is definitely the best way to get in touch with me. I sit around that darn computer every day, all day long, and I'm ready to get back in the classroom. I hate computers. Just thought I'd share that. Well, I know I work on them and they're the world and all that, but I hate them suckers because they're going to leave you stranded the first chance they get. Technology ain't all that it's cracked up to be. So anyway, that's just my thought. I do better with people. Can't wait to get y'all back in the classroom. On that note, we'll call it a day, and y'all have a good week, folks. Let me know if you need something. All right.